Luke Miller is a software engineer with an interest in software as art, game development, and Python. Today, Luke will be presenting on the different elements of a full volumetric capture stack and how Python can be used to glue it all together. Please welcome Luke Miller.
Is that better? Yeah. There we go. Thank you. Well, thank you for coming along, and thanks for PyCon for having me. I've learned a lot this convention, mostly not to write my own cryptography library, basically. I'm Luke Miller, I'm a developer. I'm on GitLab and GitHub and can email me, but I'm rethinking my social media, so I'm not on LinkedIn or Facebook, but here's a torrent link to 2 years of my personal messages that the Australian government can't secure, if you want it. I'm here to talk a bit about Project 39, which is a series of 5 to 30-second volumetric short videos. They're very, very short because volumetric data takes up a lot of bandwidth, and this is a sort of off-the-shelf solution. And it was a project supported by Creative Victoria through their Creators Fund. So the project exists because of them, and any code that comes out of it also is a result of their support, which has been pretty good. If you're looking for fidelity and quality, this process isn't for you. This is about sort of an organic, kind of glitchy kind of version of volumetric capture. Because in about 10 years, the technology is going to be perfect. But at the moment, it's imperfect. And to me, that's what's interesting about it. So I'm kind of trying to lean into that and kind of get this sort of really organic kind of look happening. I assume for this talk that you're computer literate and programming literate, but you may not be 3D engine literate or 3D video literate. So I don't want you to be left behind, so I thought a slide about what is volumetric video. It's a technique for when you want to capture a real 3D space and represent it in a virtual space. There are other techniques to do it, but volumetric capture is the most comprehensive. 360 video just fakes volume data. It actually just takes a flat video and projects it on the inside of a sphere. Motion capture, you have to pick which points you want to record, but videogrammetry, which is another name for it, captures everything, and you're only limited by the quality of your device and your ability to push a large amount of data to users. So for Project 39, we built a volumetric capture rig, and that's also today's agenda, is to go through what the workflow was. Basically, there's a physical component to this project, unlike a lot of software, which is just, well, software. So you actually have to do some stuff with hardware. You need each phone to be remote controlled. Each camera needs to be able to record a video and upload it. And then you need to process all those video files into a single 3D video. And then you need to be able to play it back to the user. And so that's what we're going to touch on all of those, but just very briefly. And if we have sub time, we'll consider some advanced techniques and improvements. So the first step is to build a tower, build a rig. This is what we did. They're just light towers from Bunnings. We did a prototype with USB cameras, but they didn't work very well. The quality is just not quite there. So I switched over to using Android phones, which you can borrow from friends and family. Most people have a couple sitting on a shelf somewhere. And they're actually quite powerful little machines by themselves. They have their own internal storage. Their Wi-Fi is pretty good. The cameras, they're high definition, which is quite low for this type of project, but it's actually pretty good for the class of cameras they are. And because they're Android, they're quite sympathetic to open source and Linux. And just an example, here is the rig in operation with one of our actors. That's 3 towers and 8 phones. And at the end of the process, you've created a 3D space with those cameras appearing in that space. I've painted in one of the towers just to give you a bit of a layout guide. But that's kind of what it will look like at the end. So I suppose we should start with a demo. I mean, the first step is you want to control the rig in some way. So I built a little Flask app, which has a web front end that can talk to the cameras. So here it is. We can see it's got 3 cameras registered, 1, 2, 3, and it's showing the last thing it took a photo of, which was the wall. But we can, and over here we have instructions we can send to the cameras, including to record videos and that, but we can also tell it to take a selfie. And that should go off, and are they going to do anything? There we go. So those phones have polled the server, and every 2 seconds, if they get a new instruction, then they try and execute it. And in this case, we've told it to take a new photo. And now we'll ask them to upload the photos to the web server. And there we go. That is our camera rig being controlled remotely from the little server. So it's pretty useful in that regard. Because if you have 20 cameras, you don't want to go around and start and stopping them manually. It can be a pain. Trust me, I've had to do it. When you've had people on the clock. Yep, so if we then look at the code for the web server, because it is a Python conference, it is just a little Flask app with a resourceful API that sort of does two things. It handles communication with the cameras, so the cameras can request instructions and they can upload videos through post command. And also the web front end also talks to the server, and you can issue instructions which then you want the cameras to execute, but you can also process videos and handle the whole workflow through the web front end if you want to. Which, speaking of workflow, it's probably a good time to jump into how I'm managing the whole thing. The thing with volumetric capture, it involves quite a few steps and quite a few different pieces of software, and Python's really good for stringing together. Even if it's not always great at some of the low-level stuff, it's always really great for stringing stuff together. And so for this project, I created a file format called voltf, and the first implementation of it is in Python, and it's just basically a way of tracking the whole project from the cameras to the end result. And that's quite important in volumetric capture because you don't want to lose data along the way as you're transforming it. So the make of and the model of the cameras is quite important later on in the process for when you want to remove distortions from pictures and things like that. And so the file format actually just kind of tracks the physical cameras and the physical scenes. So whether it's daytime or nighttime or you're indoors or outdoors, because those little hints can actually help a lot later on. The raw images from the cameras, the raw videos, alignments, if you've aligned the cameras, if you've generated photos from the images, so you may want to do a processing step between the raw image and the image you actually use, such as removing distortions and that, and then all the way through to the final playback where you can control the animation. So that's the voltf project. You'll probably hear about that over this thing. So we have our way of controlling the rig, but we actually need the phones to have their own little software. So we have a thing called voltf node, and that's a little app running on each phone. There's a screenshot of it there, and you can probably see it running on each phone there. You can write it in Python if you want it. There's a really great Python library, QPython3, which gives you all access to the entire Android operating system through Python. But it's a little bit messy, and I thought a more pure way would be to write an Android app. And it's in Kotlin. It's my first time using Kotlin and coming from Python. It's not bad. It was kind of clean. There's a lot of boilerplate. I always find when I dip into Java or Android at all, and you go a new project, and then you open up the project, there's already 100 files already there. And I was just kind of like, well, as long as you know what you're doing, I'm not going to touch any of that stuff. And Android Studio was quite a pleasant experience, so I didn't feel too bad about it. But the Android app, we'll have a quick look at that. It basically does the opposite of the server. So it's running on the node, and so it does poll the server every 2 seconds, and it receives instructions and tries to execute them. And it can also send files back to the server using a Kotlin library called Fuel for handling HTTP responses, which is pretty good. And the other half of the app is that it talks to the phone. One thing I really like about the Android ecosystem is this thing called intents and activities, where apps are very, very loosely coupled. So with the Node app, it goes, I would like to record a video for 30 seconds. You don't need to actually know how the phone is going to do that. The best app will kind of volunteer for the job. And the best app in this case was an app called Open Camera, which is an open source Android app for taking photos and videos on your phone. And I call it the MVP of this project, the most valuable player, because if you have to code your own video recorder on an Android phone, you're going to have a bad time. Because every single Android phone is different, and some of them are quite temperamental. One of them I threw in the sea. And but Open Camera just makes it so much easier. And so just with a few modifications just to automate it, I was able to then have the node talking to the camera. But we don't need to look into that too much, I guess. So we have a fully working camera rig. You may as well take some photos because this is meant to be a sort of an artistic installation. And so just all the people in the studio, you just get them to sit down in front. And so here's just some photos. You sort of lean into that kind of broken glitch aesthetic where the walls merge into people. It doesn't always quite pick up where people's heads are, and so it just will do unexpected but kind of pleasantly, or some of them actually turn out quite well. But then, it'll just give you this sort of organic, almost sort of alien quality. And I really find, to me, it's just a sweet spot for me at the moment, because this is all inside a computer, where there's no human meddling in a way, but it feels so organic. Like I feel like I'm looking at like bacteria or something, and I just think that it's so rare for me in my computer life to kind of encounter just sort of organic stuff. And some of them are quite pretty in a sort of a 70s album kind of way. So once you have your working camera rig, it's time to, you don't want to just take photos though, you actually want to take videos because it is volumetric video. And so the next step is you record the scene you want. So if you had 8 cameras, they would all record 8 videos, and then you upload the videos, and then you need to do some processing on it. Basically you need to set the in point for the videos, because all the cameras start at different times, but you need them to be frame perfect. I initially did a prototype for that in Pygame, but it was quite unwieldy, and the more cameras you added, it did slow down a lot. That was probably on me though. But then I thought, I wonder if it can be done just in a browser. And so using CSS3 and HTML5, I actually did a sort of basic video editor, and it works really, really well. Browsers continue to impress, I guess. Then you have to align the videos, or sync them. So if you've recorded them at 30 frames per second, but one camera's dropped down to 25 frames per second, you need to downgrade them all to 25 frames a second, which is unfortunate, but that's Android. I do have some code for that, but it's just a wraparound fmmpeg, which is a command line utility for handling files. So we don't really need to go into that too much, but fmmpeg is such a great little utility. If you don't use it, you probably should be. But you can do it in OpenCV as well, which is a computer vision library. But, they're all the same. Then once you have your raw videos, which you've broken up into images, then it's time to convert them into 3D objects. So if you have 8 videos, you've broken them up into images, you take the first 8 images, and then you want to wrap them into a 3D object. And that's your first frame of your 3D video. And then you move on to the next frame of those 8 videos, and you take those 8 images and you wrap them into the second frame of your volumetric video, and so on. So you've processed all the videos. But how you get from 2D to 3D is really quite complicated. And I did have a pretty good slide that explained it all, I'm sure, including a really great example with a broom handle. But it's a bit too complicated for this talk, and I don't particularly understand it myself. So I thought I'd save some time and skip it. In fact, you can do it with open source software. So Structure from Motion is a good example. I've blotted them out, whatever. Yeah, so rather than go into that, I thought it would just be quick to use an off-the-shelf tool that I was familiar with called Metashape, which is quite a powerful tool. And what I like about it over the current open source ones is it's very visual. You can see what's happening, and so you can correct errors a lot quicker. So I had limited time for the project. So rather than write some of those libraries, I just wrote a little Python project for converting between my VoltF projects to the Metashape projects and back again. And it handles like 3 or 4 steps of the process. So generating a point cloud, generating a mesh, and texturing. But you can replace those at some point with some open source solutions. I think MeshLab and Blender are actually best in class. And if you did them, if you use those, you actually probably get better results than Metashape. But actually, to show you just how you can use Blender for stuff like this, there's a great Python module for Blender. And so you would load your object into the scene and then iterate over all the objects in it, and any of them that are meshes. So this is to decimate a mesh, because you don't want to pump 2 million vertices through a video file. You just want to decimate it a bit. Probably didn't introduce that very well, but oh Yeah, so you want to decimate it, so you create a decimate modifier, and then you apply it to the mesh. And it's super fast and super easy, and it probably gives the best result available. So it is possible to do, but just not for this project. There are some other maths that I wanted to go through that I quite like. I don't know how much time I have left, though, but... Oh, OK. I am talking a bit fast. Well, then I'll go through these two slides, because these are kind of my two favorite parts of the maths. If you want to move your cameras into a 3D space, you need to find a relationship between the two cameras. So you have a bunch of cameras, you take two of them and two images from it, and you want to compare those two images and find the common features. And it does involve some pretty heavy maths, but the high concept is pretty cool. It finds 2 points that it thinks are identical, and then it goes, are the neighbors kind of identical? And if the neighbors are kind of identical, then it's probably the same point, but from a slightly different angle. And we can see here it's just been run on two images of a book, and it's found all the common points, well, a lot of the common points. And from that, you're able to work out the cameras in relationship to each other. And my other favorite part of this process is texturing. I guess growing up, I've always wondered how you get from flat images and a blobby mesh to a beautifully textured mesh, full color. And when you look at a texture image, it just is quite nightmarish in its own way. But then coming out of this project, I found that it's actually a really simple solution that someone came up with. And the assumption is the photo closest to something is going to be better quality than a photo far away. So you may as well just use the closest point in the closest photo and use the color from that. And it turns out it works extremely well. So often when you do these projects, one of the things you're surprised at is how readable text is, because so much of it is blurry and garbled, but often the text is crystal clear, and I've often wondered how that is. And it's just because it's using the best closest photo, which is pretty good for text. So once we have processed all of our images into meshes, so for a 4-second video, you'd have 100 frames if you're going at 25 frames a second. So that's 100 meshes. You need a way to play it back to the user. I use a 3D engine called Godot, which is a 2D, 3D open source game engine. It's pretty good for small teams, and it's Linux as a first-class citizen. It does have some rough edges, but it's pretty good, and the way they structure their projects is pretty cool too. We'll have a quick look at the playback for that. It's pretty simple. This is the scripting language for it, which is Python-esque, but not quite Python, which can be a bit annoying. It's just your classic, if the engine's running at 60 frames a second, you need to and you're only playing back at 24 frames a second, you need to remember where you are. But basically, you get the frame you want, remove the old frame, load the next frame, instance it, and add it to the scene. And you can actually get pretty good results. So here is a 4-second video from our first batch of filming with one of our actors. So it's about 1 gigabyte a second, uncompressed. And compressed, you get it down to about 150 megabytes a second. For a 90-minute film, that's about 800 gigabytes. So it is very intensive kind of information. But it's kind of fun and cool in a way. And that was only with like 8 cameras. If you had 20 of them, you get much more. But just to kind of wrap it up, in a few minutes, what is kind of, to me, the potential for volumetric video is not just playing it back to the user. Because you have the full spatial data of a scene and you're playing it back in an engine, like a 3D gaming engine, there's a lot more you can do than just play it back. So, for example, you have complete control over the camera. So if you have a volumetric video of a stage play, you can sit in the audience watching it, or you can get up on stage and walk around, or maybe even view the play from the perspective of one of the actors. Because it's in a 3D engine, you have complete control over the lighting and animation. So you can apply effects to your video that just never existed in real life. And finally, because it's a game engine, it's as interactive as you want it to be. You've got control over the shaders, you can add sets, you can add other characters, And because each frame is discrete, you could actually add conditional branching logic around every single frame. So you could actually do quite an interactive character who's using a real actor, but they react to where you're standing in the game and things like that. So I think the potential for volumetric video is pretty cool. And it's just been a fun little project. I thought I'd share it. So I think pretty much that's almost it. In the future, I want to add more cameras to it, replace the remaining steps with a full open source stack, tidy up the code a bit more, and release it on Edge. But other than that, thanks. I hope you enjoyed this brief look into volumetric video.
Thank you so much for the talk, Luke.
It was a brain dump. It really was. Sorry.
Please accept this mug as a token of the community's and the convention's appreciation.
Thanks for having me.
Thank you.
Yeah, of course.
Luke is open to taking some questions now. So did any members of the audience want to ask a question?
Thank you for that. Wondering about the sort of processing power and the machine that you used to chew through that and how long it took to process.
I had a budget to buy one of the new Ryzens, but I wimped out at the last minute and used my old tower. It takes, for a second of footage, it takes about an hour of processing, I think. So, and that's on like a 4-core machine. So it can go parallel very, very easily. In fact, it's the perfect task because if you've got 100 photos, you can spawn them out to as many different cores as you want for comparison. So you can speed it up quite dramatically.
I was wondering if the pipeline is fully automatic or are there some manual steps in it as well? Or?
It is fully automatic except for 2 steps. So you have to load the project file into Metashape, but then that will export itself when it's done. So that's one of the drawbacks of using a closed source product like that. You can't just hook into it. And the other step is it's worth doing a little bit of cleanup on some of the frames. So you saw like the 4 seconds of footage. Maybe every 30th frame is just not aligned at all, even though none of them looks particularly aligned, let's be honest. But some of them are way out, and so you can just actually just manually tweak it. But I mean, that's common for like motion capture and other animation techniques.
We have time for some more questions. Did anyone else have any questions?
On the final result, can you use like any error correcting type of algorithm?
Sorry?
At the last final product, can you use like error correction to make it more smoother and increase the quality of the image?
It's unlimited. I often do wonder if you could scale up. It's basically garbage in, garbage out. So the resolution of the camera is only HD. So that's actually very low for photography, and there's not that many of them. And as you could see, the backdrop was getting pulled in a lot. So you actually put like a black backdrop behind people, you get a lot better quality already. I mean, as far as smoothing goes, that was very mild smoothing. You do a little bit of smoothing, and you do a little bit of gap filling as well. But the more you smooth, the less detail you get, in a way. It's just one of those things where you kind of go, what do you want? Like, how much do you want to do? So, and you can use reference images. So this is a slightly advanced topic, I guess. So when you've got an actor sitting there, if you take a bunch of images from around them while they're stationary, you can use those images to kind of correct the video later on, especially if some of the images aren't being picked up by the camera. So in a way, you can go from your 8 cameras to 20 cameras. Yeah.
Looking at the examples that you showed, it looked like most of the rigs you had were sort of across maybe say a 90-degree angle in front of the actor. Did you experiment with going like past the line, going more than 180 degrees, or are you constrained by devices or processing time there?
The best suggestion was a friend of mine, Avery, and they were just walking past the rig one day, and they just went, "Why don't you try turning the camera sideways, Luke?" Because we were getting a lot of torso, and we were just trying to capture the head, people's heads, because very small space. And just turning them on the sideways gave us an extra 20, 30 degrees. It's probably better to, if you have much experience with photogrammetry, which is taking photos to convert into a 3D object, you really need overlap. And it's better to, personally, I think it's better to capture a smaller space than get back to your processing and find that none of the photos are overlapping. I think with 18 cameras, you would get a ring around people. So it's a good question.
How much of the camera field of view is wasted? So if you know what I mean.
Yeah.
How much of the camera field of view is wasted, if you know what I mean? And if that's a significant proportion, have you considered putting mirrors in the field of view to have a second smaller view that you can use as well?
Well, you know, so photogrammetry it has its limitations. It can't do smoky things. It can't do reflective things because it just has nothing to hook onto. I did photogrammetry. So if there's a mirror, it may think that, so just say you've got a couch and it's in a room and there's a couch in another room, in a mirror. When it comes to align the photos, it won't know which couch is real and which one's a reflection, so the cameras will fight each other. And that's very common with glass and reflection. And also police cars. I think they paint them in some sort of weird paint because if you photogrammetry a police car, it distorts more than any other car. That's neither here nor there.
Did we have any more questions? No? Thank you so much for your talk.
Cool. Thank you.